Before solving simultaneous games, we should know two important terms. First one, best response. Best response is the action that gives the highest payoff given the other player's action. It's simple, right? The second one is Nash equilibrium. You probably may heard this one before, but here is the right description. Nash equilibrium shows the list of strategies, where no player can be better off by switching to some other strategy, given the action of everyone. So there should be a balance in the Nash equilibrium. In the balance, everyone should be happy with their payoffs. By saying happy, I don't mean the emotion. I mean there shouldn't be any better option for any of the players. In normal forms, if for a cell, there is no reason to switch the cell for any reason, that cell is the equilibrium. Don't worry if you couldn't understand it well enough. Now you will, with this example. Consider this game. Let me just write here Alex. And here Kevin, for the simplicity. This game is a two-player game. Alex is the row player and has 4 options, top, high, low, and bottom. Kevin is the column player and has 3 options. You can see the outcomes of each cell for Alex and Kevin. We'll try to find the Nash equilibrium based on these points, and it is one of these cells in this table. Remember, Nash equilibrium asks for a cell that no one wants to change their decision. Okay. For this cell, Kevin chose left and Alex chose top. Do you think Alex wants to change his decision? Here, Alex gets 3 points, but here he can get 4. So, this cell cannot be the Nash equilibrium, since Alex wants to change. For generalizing, we fix one of the player's decision, so let's fix this column left for Kevin. Then, we should ask, is the highest number in this column? No, it's not, then it is not the equilibrium. Next cell. Is 2 the highest one in this column? No, then we can eliminate this cell. In this one, there is 12, so let's put a cross here as well. We got 4 here, but still it is not the highest. These cells are not the Nash equilibrium as you can see. Let's look at this cell now. In this cell, can Alex gets more points by changing his decision? Remember, we fixed the Kevin's decision. So we know that Kevin chose middle. Can Alex get better by switching? No, 5 is the best response for Alex. If this is the case, we can then check it for the second player. So look at Kevin's perspective. Again, this time we fix the row. So we'll consider only this row. Can he get better outcome by switching? No, 4 is the best response for Kevin. Perfect. In this cell, neither of the players wants to change their decision, so this is the Nash equilibrium. Before ending this lecture, I want to take your attention into the last cell. This one has higher points for both of the players. We chose this one as Nash equilibrium. But with this one, we could get higher points and still, it is not the Nash equilibrium. Why it is not the equilibrium? Because Alex wants to get 12 instead of 9. What we can learn here is, Nash equilibrium does not have to be the highest points. There is no rule for that. By the way, there is another keyword that looks to the highest points. We'll come on that topic in the next video. But for now, you should know what Nash equilibrium is.